Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter written in Swift. We've been going for a few weeks now, a few hours a week. We've gotten integers and floating point numbers to build and be interpreted. And we've moved on to the Boolean type, which is an example of a custom type. Let's see if I have the documentation up here still. No, I seem to have lost it. Here we go. Okay, so we've got literals true and false. They're both of type bool, and behind the scenes somewhere in as a sort of predefined system type, we have the notion of a custom type, and in this case we have type bool equals false or true. Okay, you can attach types to these custom types, but we're not doing that for booleans. And we got a little ways into it. We got a little distracted. I don't know. Ended up having to write this equatable stuff to tell if two ASTs, we have our types, Elm types, and AST, abstract syntax tree. I don't know. I keep explaining that. Maybe that's a bad sign. Could I just call that tree? Would that work better for now? At any rate, we have AST that represents the tree we're building from the parsing, and Elm types that represent, well, so far only number and float, and we're just now adding custom types, a string and a set of strings. So the string is the name of the type, like bool, and the values are sets of strings like false and true. Now we know that's not going to be sufficient in the long run because we have these additional types we can add in, sort of like Swift has these additional types in their enums. And this type, custom type, is very similar to an enum, basically, in the way it operates. You get to pick one, and you have switch statements and whatever that have to cover the values. All right, and so we started adding this in. When we added this, it complained that we weren't really doing equatable anymore. It generates one, but apparently this made it too hard. I want to explore that, but we'll get there. Okay, and then we have a failing test. Check parse. We're parsing false. We expected to get a custom value false, whose type was a Boolean that contained false and true. And what we got was a question mark and a set of question marks, which is some sort of dummy default we threw in there. Okay. Let me reorganize a little bit. We won't need lexer stuff, I don't think. All right, what are we getting there? Handle custom type Boolean. Okay, great. And I'm in an unaccountably good mood today for some reason, so I'm always happy to have that. Okay, so we've got our test. We get something back. I'm still a little, I don't know, put out that this AST thing has to be a custom equatable. It's a pain. And a custom hashable. That I can kind of understand because we have more values that should be combined in there. But, okay. Okay, we don't care about that so much. Maybe we don't need this at all. Not helping us. Okay, so let's track through the parser. So we call parser with false. It comes into expression. Expression sees an uppercase name. We did that yesterday with the tokens. And he says, oh, return. Well, what's he going to return? Custom type. Here's this question marks. Now, we can do the sort of quick pass sort of thing. Elm type, custom type, bool, and this is false, true. Okay, let's start here and get this passing. Now, what is really going on? Okay, let's see it first. All right. So we got our custom value false back, and it got classified as a Boolean, which can take on false or true. All good. Where's this come from, though? Well, it's a predefined system type. Excuse me. And so we need some sort of. It should have been looking this up somewhere, basically. I mean, normally we get some word like this, and we're going to try and interpret it as, well, at least for now, as a custom type or a custom value. The values have to be defined somewhere before you can go around using them. So we've got to be looking it up somewhere to get it. And in this case, bool's predefined. So excuse me. I think what we're going to do, well, basically, I want to have something that represents, that maps from the name to the type. It's a little weird that the type knows the name as well, but let's extract this. I lost my keystrokes I added for extract method and all that. I gotta dig that back out, figure out how to make that go independently. But let's call this lookup custom value. Okay. Now, let's define something. Let custom values equal, I'm just going to make a dictionary. False goes to, well, let's pull this out. I'll be happy when Xcode grows up. I should switch over to, what's the app code, the IntelliJ version, or JetBrains. I want to extract a variable. This is a bool type. Now there is a way to move this down. Let's learn that. I thought there was a move line down. Sorry about my phone if you're hearing that. Select column up. Control Shift up arrow. Move line down. Command Option right bracket. A lot of work to do that once. All right. And we want the bool type to be what it gets back. Okay. And let's return custom values dot, well, what do we call it? Oh, do we just use brackets? Name. Let's pass in the name. And for now, let's just do that. Okay, so we're moving it in. We're kind of creating it into existence like this. All right, so we got enough for false. Let's move this up. I want this to be set up here. And maybe it maps string to Elm types. And we'll sign it in here. Okay, so this refactoring, I'm promoting this up to class level, and I'm initializing it here. And let's make sure things are still going. Okay, and we'll add true. Custom bool value. And I think that works. Custom value true, custom type bool. All right. And this should fail. Okay, found no while unwrapping, yeah. Let's add true. Okay. Oh. We're quicker than that is, I guess. Okay, let's see. I don't need this. All right, custom types, custom values, gets maps the two starter values. We'll probably have more to do at some point. Okay, let's run the test again. But that failure there is telling us if we don't have the name in our dictionary, we got a problem. So I think that's all right. Okay, we got Booleans. Let's take a moment and push them. Support bool custom types. And then let's deal with the syntax error. Well, let's rename this. Whoops. Check successful parse. Okay, and then we have a situation we want to check a failed one. Unknown custom value. Do we have Elm? Let's see, where's our AST? I think we have an error clause in our AST, maybe. Elm ignored. Let's add an Elm error. We'll flesh that out with more information later, but for now, okay. Let's get the test going right first. ast.elm error. And this is parser input.parse. Okay. And this complaint, we don't have error anymore. I don't know why I sometimes need the dots and sometimes don't. Okay. Anybody else going to complain? Otherwise, I think this test should have that exception again. Yeah, found no while unwrapping. Okay, so what we want to happen, and I don't know if we get, well, okay, let's just stop. Returning Elm types. Well, maybe I don't need that in the AST. Maybe this is case error unknown. I think error. And let's take this out of the tree for now. Now somebody else has got to complain. There we go. Okay, error. Now, why could we do this before? I don't know. That seems weird, doesn't it? Like, RHS is an AST, so now I got an AST versus an AST. I don't know. Let me do this again. Should fail still. We haven't applied it. Now is that the behavior we want? It probably is. Okay, this thing can be or Elm types dot error. Okay. Okay, we're going to return, well, if the type equals Elm types dot error, then we're going to return AST dot error. Otherwise, return the looked up value. No, otherwise return the type. Okay, I deleted the AST error, so here I am circling around again. X types to return expression of type AST. Return type is AST. I guess I messed that up. How's that? Okay, custom value. No member error. Can I put this back in? Yes, I can. Okay. Now this. It seems like I can get the underlying value or something. No. Okay. AST should have a member error. Yes. Okay. I can't get through the syntax here. Type AST has I'm going to drop this word Elm error from here. I'll get them all in a moment. Okay, AST has no member Elm error. Now, it's often the case that the error handling is kind of the worst part of this stuff. It definitely adds. Oh, yeah. Okay. So this is what I was worried about. Cool. Well, we can do this then. I don't know why we have to, but we can. Well, here's error. RHS default error, return true. Elm ignored, RHS return Elm ignored, return true. There's gotta be a better way to do this. Now I got both things going. I got this caselet thing. Well, that's when you need a value to compare with. Might be acceptable. I mean, in this case, it's good we don't have infinite stacks, right? It would take much longer to fail that test. All right. So where's our parser test? Check failed parse unknown. Okay. Unknown custom value. Right. Yeah. Let's see. So let's commit this. Unknown custom value. And now, what do we want to do with this? Okay, let's see how we're looking here. I'm gonna AST, let's deal with that one first. I'm still, why does this need this? Okay, let's make sure it really does. I mean, it seemed pretty clear yesterday, but I don't know, sometimes I get going. Okay, so here I am struggling. I don't know, maybe I had changed the types here or something, but apparently it knows enough to generate the equatable for this. Okay, so let's commit that. Now, do I need the custom hashable? Yeah, generic because I put it in a dictionary. All right. I'm tired of Elm ignored. I'm going to rename it to ignored. Oh, nice. Try again. Rename Interesting. Bug. Okay, we'll do it this way. Should get some complaints on the build. Missed one. All right, and ignored is, I think it's how we're tentatively handling spaces and things like that for now. So, okay, I don't like these things where you use the same prefix over and over. It was nice not to be confused about the types, but now this may get trickier. I guess lowercase integers should be okay. My rename, yeah, apparently it's, well, I don't know if you call it a bug. It seems like the cases don't rename. Okay, I don't think that's a reserved word. Integer. Might be a test or two. Yeah, so I think I was distinguishing because you do have the two different kinds, so there's some ambiguity in the word, but that's okay. So we renamed Elm integer to just integer. Elm float. I'm not going to bother with automated rename, but we'll take this word. Float. Probably interpreter again. And we missed that one. Tests seem a little slow, don't they? .036 seconds seemed longer. Okay. And one more, I think, right? Custom value. Okay, Elm custom value. Nice. All right. Let me take a peek here. Great. Okay. Let's see. So custom value. I think I'm happy with that. Let's take this AST since I keep having to explain it. Let's just call it tree. I don't think that's a used word. Let's hope we can rename the enum. Oh, I'm gonna quit Xcode and restart it. Okay. Rename failed. It's almost there. You can see it's got all the places. All right. I'll call it tree. This almost sounds better, doesn't it? You'd think there'd be more. And I could do an automated replace, but I find it helps to kind of get to be able to take a look at these things as you go by. I may be starting up a new, no? Okay. And we'll do the file too. Yeah, we were talking on Twitter about like it'd be nice to have something that just filled in that message for you on these refactoring ones. Okay. Elm types is growing. Let's go ahead and extract that. I don't think I need import foundation. All right, so we'll just pretend we're making a new type, new file. Swift Elm types. Has those. What? Oh, it just needs to wake up. Tree. Wouldn't hurt to leave that on either. Okay. Now our tree. Well, let's take the step. Did I really have to do this? Global function assert equals. Oh, I gotta say it's equatable. Could I have left that out? It's all. I had a very ragged, 15, 20 minutes yesterday trying to get all these things together. And it turns out they're just not even needed. And I think we didn't even use that before, but let's. This is looking a lot less crowded now, but that's okay. Let's make sure we're still good. Okay. Remove unneeded equals method from tree. Good. All right. Now this, I'm almost thinking custom values isn't the right name for what this thing is. It's really predefined custom types. And I don't think this thing's going to sit here as a dictionary for very long. We'll see, but it seems it's very clear to me that it's going to be its own type at some point. It's the symbol table, in compiler terms. Lots of times you have a parse. When you parse, you generate a tree and a symbol table, and the symbol table keeps track of all the names. And when you need something, you look it up. And symbol tables often have some sort of nesting structure. So if I look for a name, like we look for bool, I don't know. Let's try it in the REPL. Elm-REPL. Okay, so I could say type. Am I doing that right? Type, yeah. Type my bool equals. Can I say false or true? I don't know if it'll let me duplicate that. It does. Okay, so when I say false, how about my bool dot false? No. So I don't know if this is what's going on there. It's a type definition, right? So I don't know how I get to this thing. So this may be a consequence of the REPL having slightly different semantics, or maybe there's a real gap here, or maybe I'm completely misunderstanding the situation. But when I say false bool or get false bool back here, it's not looking. It's not. It hasn't realized it's a my bool. Okay. My bool dot false. My bool's not a module, which is apparently what the name dot thing is. I'm kind of surprised it didn't tell me when I defined my bool, like, hey, you've defined an ambiguous custom value, or if it had just let me override bool, which seems like a good way to get yourself in a lot of trouble. Let's try a slight difference. Can I use this again? F or T? Ooh, I don't know about my bool. Okay, F. REPL dot. Let's try REPL dot false. No. Okay, a little gap in there, but at any rate, you definitely get situations where, well, I don't know. It depends on the language. So, like Pascal had this notion of you have say a subroutine. Inside that, you can define another subroutine. Inside that, you can define another subroutine. And if you reference A, it's going to try your local, and then next to the outer level, and then to the outer level beyond that. C simplified that quite a bit, and you had local variables and file level global variables. In Swift, well, I don't know what we're doing there. If I put something in, let's just throw it in. Can I make well, we got lexer, right, is a top level thing. So I could say let lexer equal 3. It's not complaining, okay? Yeah, and then print lexer. Okay. But it had to keep track that lexer in this context is the local one, and in this context it's the class level one. Okay. And where it's going to get messy, and I'm not deep enough in the semantics to know, but when you start doing closures, right, you're capturing the local variables kind of at the point where you are, and it's kind of a mess. I mean, it's people have worked through the semantics, not me, but people. And there is a way to do it. I mean, I remember hearing cactus stacks. So it's as you create these closures, they have to kind of branch off like is it saguaro, the big tall ones? That you need stack structure kind of like that, not just a simple stack, but a kind of compound tree like stack. So we'll see, but at any rate, I would expect that as you can see with the module stuff, that we import names, we use names. I import this operator or this function, and I expect to get the one I imported, even though some other file I indirectly imported may have defined its own. So there's definitely something going on there. So I would expect this to grow up and somehow allow references to other symbol tables, or I don't know, maybe call them scopes or something. I'm not sure, but it's almost certainly the fact that if you don't find it in your thing, you're supposed to look somewhere else until you get to the back, to the last one. And then it's just some sort of failure, which we've simulated here. We said, no, if you don't know the type, you definitely have an error. Okay. So normally we take a break about now, so let's take 2 minutes. We'll come back and tackle the next thing. I'm not quite sure we're ready to move off Booleans, I think. Oh, we got to do the interpreter. So we'll do the interpreter when we get back. All right, so see you in a couple minutes. Hello, welcome back. All right, let's look at the interpreter. So right now, interpreter takes a tree. We parse things into a tree. It probably needs to take a symbol table too, but we don't have that yet. And in this case, we won't need it for Booleans, but we're kind of peeking ahead into the future. It's allowed. But at any rate, we're going to interpret, and now we'd like to do a test for a Boolean. Let's make sure those get evaluated correctly. So interpreter tests. These are looking similar too. Let's extract this. So let's make this func check interpreter succeeds. And you're going to give me an input string and an expected output. And it's going to look something like this. Here's my input string. Here's my expected output. Okay. And this can call. And we'll just comment briefly. Okay. I've definitely found it to be the case that for compiler type stuff, you end up doing the same kind of thing a lot. Here's a string, my input, and compile this thing or compile and run it, and what do you get? Okay, so notice it is parsing, so this is kind of an integration test, but we've convinced ourselves the parser is okay. So for what it's worth. Okay, 42.5. Okay. And that was it. Okay. I'll have to check that later. All right. So now we want to interpret Boolean false. False, and we expect to get false of bool. And where I'm getting that is just the REPL. Okay, so we're trying to imitate that. I'm not sure we'll always be 100% compatible. And we expect this to fail. We'll get some print message. We don't do this yet. Okay, bool is not equal to nothing. And did we get a message? Our interpreter said unexpected input. Yes. Okay. Very good. This is case tree.custom value. Let value, let type. Okay. Output.append. Value. Colon. Kind of a pity we can't combine these. Maybe we can. But let's try for format type of type. And yeah, this thing, okay. We'll get another error because of the exclamation point. Okay, and yeah, unexpected nil. So we try and look up elm-types.custom value, and we get nothing. Okay, so let's make this more of a switch on the type. Okay, so switch value case. Well, let's do error. I'm making this up just to get through the case. case number. Probably have to say return. Custom type. I don't know how I say this. That. Let pattern, subpattern didn't define. Okay. Types, we got 4 cases. Yep. All right. And I expect this to pass along with the other ones. And now type string's not used. Let's get rid of that. Oh, capital float. I'll trust my space deleting. So we make interpreter support custom type values. Okay. So once the tree is structured, the work is pretty minimal on these leaf types. So notice our trees aren't very tree-like yet because nobody nests anything. But when we get to expressions or some of the statements, the structure will be a little more of a tree. Okay. Okay, let's just look around, see anything. That's weird. Tree's pretty simplistic. That's kind of what I'd expect. These are pretty good with that helper. This guy's still, he's big and growing, and I don't know a good way around that. Oh no, is this? Oh, this is parser. Well, he's small and growing. I guess he's not as obnoxious as he could be. This my input thing, I think maybe we should pull that out. Let's make this just called input and see how that goes. So we won't need this anymore. Oh, I can't just do that. My input. Let's do that and see who complains. I would have thought somebody did. Do we really never reference input? Huh. Okay. Let's rename this. So it appears it has trouble with classes. I'm sorry, with enums and cases. Right? Okay. Name. Cool. And let's extract this. Clean. Rebuild. Rename, or no, extract input to input.swift. Yeah, there's things to do here. Okay, parser. Our grammar's emerging a little bit. Okay. And parser tests, that's pretty minimal. Okay, but I think we have done this. So this is the third. You can see I'm still learning to type 2021. Okay, that was not bad. Those types came together pretty quickly, and we've got some capability for more general types as we get those going. So that's something. What's next? What else we got? I guess the other thing I like to do. Okay, well, here we got a couple of things. We didn't update this grammar. Oh, I don't want to open it that way. I'm trying to accumulate a legit grammar for things, so I think this card is my best explanation so far. Where's my show and finder? Where did you put it? Oh, on the other window, of course. Let me just click it. Okay. Grammar. Well, that looks like about what I had, doesn't it? A/B test. Oop. Bloop. Yep. This one's the right one. Okay. But we're adding. Okay. So let's make a new page. Oops. Wrong choice. Cancel that. Add a slide. I think agenda will work again. Okay. Okay. So we got custom value goes to, let's just say bool value for now. You can either have false or true. And we will grow this up as we go. Okay. So let's call this one white space or space. spaces. Duplicate that. Get rid of this stuff. Move this up. Cut that. Did that the hard way. Expressions. Float literal, integer literal, or custom value. Okay. That's where we are. Eventually somebody will kind of correct me on this, I'm hoping. Okay. Oh, we did that. Yes. Okay. Yeah, so, whoa. You go faster than you expect sometimes. All right, so let's, why are you not, there we go. All right, now we got to choose. So I really try to be pretty strict. I sometimes do research about stuff between sessions, but I don't. You get a lot of it raw. Put it that way. All right, so we've done the comments. We've done literals up to here. I don't think we're going to learn a lot from the character literals just yet. They, we can do it, but it's not going to introduce new concepts. I don't think it's just going to be matching whatever characters and strings are. Operations is a whole big bag of worms. The problem I have is Elm has, well, my understanding is they used to have user-defined operators with precedence and associativity and all that. At some point in the last release or two, it seems like they took out the user-defined operations with precedence, but the main operators, there's still a facility for defining the precedence and all that the system one uses. So you can go through the system files and you see these precedence declarations and stuff like that, and you can't make them, but the system can. So there's some complexity there that when you have, so in recursive descent parsing, which we're using at least tentatively or minimally, normally if you want different levels of precedence, you have different rules, and you write the rules certain ways to get either left or right associative, and you have sort of levels. So, expression goes to terms goes to factors goes to something else, and if you have intermediate layers in there, terms do pluses, factors do stars and divides, and if you want other layers, you have to have more levels in your grammar, or at least that's the way I know to do it. Now we can do, we've got some shortcuts we can do in the grammar writing, so it's more like term plus or minus term repeated, so we can kind of mix regular expressions and grammar rules, which works out okay, but the levels is kind of an issue. And especially it's an issue when you want user-defined levels, because either you're going to predefine a bunch of levels and then let them plug into those, which may be doable, or you're going to use some different parsing approach. And the different parsing approach I know that does work for that is operator precedence parsing, which is old school. I mean, like really old school. But it's designed to handle that. It's got some limitations in how it handles errors and things like that, so it's not perfect. But my guess is that if we're going to do defined levels of precedence that we probably want to do something like that. And that's a kind of a big can of worms. Basically, you basically when you see like 5 plus 3, you think it's an addition, but you see a times next. And now you have to decide, is times higher precedence than plus, and is it right associative? Or, well, no, associative is when you got the same operator, but 5 plus 3 times, you got to say, oh, the times is higher precedence. Hang on to that 5 and go ahead and parse the 3 times whatever first. And that's, yeah, that's a little tricky. And same thing for associative. 5 plus 3 plus, it's like, is that 5 plus 3 plus 2? Or is it 5 plus 3 plus 2? Okay. The operator precedence, you basically build this big matrix of, given this operator, if I see this one, do I accumulate or do I defer or what do I do? And gosh, it was funny. I would have sworn that I never had implemented an operator precedence parser in a compiler, but I was going through some papers from like, I don't know, 15 years ago, and found that I had in fact written one once. But yeah, that's not much to go on. So it would be a relearning experience for me, and we would have some interesting things happening with that. But I'm kind of that's one where I kind of like know how it's done in principle. I remember enough of it to do that. I don't think I'll learn a lot from it. So I'm looking for things where I'll learn stuff. Let's keep going. Lists. Okay, so this introduces a little bit of parsing stuff. So we have to be prepared for brackets and commas and colons. Maybe colon is more of an operator, I guess. This one, I was kind of thinking this might be the next one, because if you got ifs, you kind of got something. You don't have a full language yet, but we've got values and we got ifs. We can write expressions like this, but return 42 or 37. If false, return then 42, else 37. Would be interesting. Now, I don't know if then else. I don't know how this gets interpreted. There's definitely, I mean, it's not visible in the spacing, but there's kind of an ambiguity here. I guess you don't have an optional else clause, so you don't have to worry about that. So it's going to be pretty straightforward. But this one, you can kind of see an associativity thing going on or something. It's like, if this, then the n+1 else. Well, else what? Well, else takes an expression. What's the expression? If key equals 38. And that's kind of a difference in Elm. Everything is kind of really expressions, not, we don't have assignment state. Well, we do have assignments, but I don't know. Yeah, maybe. I mean, I think this is taking if Boolean, then expression, else expression is what's going on there. And I assume you're required to match these types. Okay, here's conditionals. Now this is interesting. It gets into the pattern matching stuff. Here we're matching custom types, and here we're matching literal values, and I don't know what you call this when you take these apart, but this sort of stripping off the front of the list and doing stuff with it. Indentation sensitive, so there's something going on there. If you don't align your patterns, there's a problem. Records, I think, is more of the same, kind of like the lists. I don't think there's anything interesting syntactically. Well, there's a little bit. And this updating is a little funny. Update many fields. Yeah, there's a little bit there. Function's another good one. It would be nice if we could define a function, wouldn't it? Anonymous functions. Right. Yeah. So we can either have the lambda functions or the ones with an argument. You can pass an anonymous function in. There's operators. There's a whole pile of those. Let expressions that will let us get some ways, and I'll also point out we could allow one operator expressions, and then if you have let, you can build up the whole thing. More interesting assignment approach. Destructuring assignment. Okay. Functions, modules, now you're getting out there, right? Type annotations is interesting because your functions have the option of this. If you don't have it, it'll infer it. Custom types. Okay, I mean that's not a huge language. Okay. What will teach us something? I think maybe if. One of the reasons I wanted to do bools was so we could do if. But there's assignment. Where do we see assignments? Origin.x. Origin equals. Well, you can definitely do an assignment. Name equals something. Okay. Let's try this. F equals false. Print F. Yeah. I don't know if I can say F equals not F. No. F equals F and F. Okay. We'll have to look up the operators, I guess. Yeah, so if we had functions and if statements, we can, since they allow recursion, we pretty much can do anything at that point. So I think we'll do ifs and then we'll do some sort of function. I'm dreading it in some ways. This, we didn't really see this called out, did we? I'm dreading it in some ways because I know we got that cactus deck thing I talked about and all the closure stuff and all that. And they also, we saw you can define functions with or without arguments, but if they can be anonymous. Elm also has curried stuff, so you can define it with 3 arguments, but give it 2, and it creates kind of a new function that only takes 1 argument. Okay. All right. So I believe our structure is if expression, then expression, else expression. And let's see if we can do different things. So let's say if true, then 42, else 37. All right. If true, then 42, else who? Okay. 2 branches need to match. Let's say if f, then 42, else 37.1. Will it infer the difference? Yeah. So it'll promote. X equals 3. X. If x, then 42, else 21. Okay, he must have a bool. Okay, so I think we see it's if bool, then something else something, and the 2 somethings have to be constrained to the same parent type, I guess we can say. Compatible types, maybe that's the way to say it. And part of that is just floats and ints get treated funny. What did we get for the 42? Okay, yeah, so it did promote the int up to float. Interesting. So if your number or float, I guess your type is float. So we've got some type inferencing or something like that going on. All right. Well, we have no notion of keywords yet in our tokens. So we would like separate tokens for if, then, and else. Actually, we don't even do lowercase words yet. So I think the reserved words appear to all be lowercase. There aren't a ton of them. Okay. But let's do that. Okay. So if, then, else. So I think the way I look at it, I'm going to just do the lexer, then the parser, then the interpreter, I guess. I can drive from the interpreter all the way back, but in the end, I know I'm just going to sit down and write a lexer for it. The other thing I'm looking at here is, I don't know what this is. I've got parsing. That's parsing. Tree is, well, it's sort of an interface to interpreter and parser. This is low level. This is a lexer. This is medium level. It kind of goes with the tree. Input's low level. Okay, so let's kind of get levels. So low level is the input stuff. Interpreter is much higher level. I don't know what this thing is. Put him up there out of the way. Whoops. Okay. And then this is view stuff. So we need to do some splitting up at some point. Our content view just says, hello world. So maybe that's the thing to do. We'll get the if working, and then we'll get our REPL so you can actually type in it. And you should be able to type what I just typed. If true, then 21 else 33, or our 4252.1 in bool values. Okay, lexer and lexer tests go below parser tests. Character category tests go at the very bottom. Okay. Lexer tests. So we want to test reserved word if. I think I can live with that. If, and I'm just, I don't think there's a big issue. I'm assuming the lowercase names work like the uppercase names, that they can have those values. But we're not, I guess I'm worried, when do I have to worry about end of file? Only if I have something that does things that are not other things. Like our comments. I was looking for braces or dashes inside the comment, but if you end a file in the middle, you got a problem. Okay. So we want to see token dot if, I don't think I can use if by itself. Wow, can I? That's interesting if I can. Where's my tokens? All right. Case if. You gonna let me do that? I can't believe it. No. I'll say if word, if I want to say verb, but it's not a verb. If it's really if reserved word, or maybe reserved if. Let's go there for now, I guess. Okay. This should fail. I think it'll compile. I have to say, okay, it got an error. These car insurance people, it's like, I wish my phone would just, if you're not on my list, you go right to voicemail, and then these people that don't bother with voicemail can just go away. All right. We need our lexer to do stuff. Okay, so I think, well, what we've got here, basically, it's a similar situation. We've got the lowercase words. How about I use lowercase letters to reflect that? Okay, and we're going to return lowercase name. Okay, and where's uppercase? Now, this is about as complicated as that. The only difference is it starts with lowercase a to z. Lowercase name. We're going to keep. We only get in here if there's a lowercase letter. We're gonna parse any of these letters and return token dot. Well, I guess eventually we're gonna return this. We'll borrow that for a moment. Okay. If a string of token is if, can I do this? Return token dot reserved if. Otherwise, we'll return token dot error for now. Okay. This should pass. All right. So now I'm gonna pretend that I had written this first. Lowercase name. Okay. This will fail. Oh. For the wrong reason. Lowercase name. We need to put that token in. Somebody's bound to complain. Well, they didn't with reserved if, did they? Interesting. Okay. Where's my lowercase name? Okay, and just make sure it's failing for the right reason. Seeing as I messed it up once. Oh, well, yes. I gotta look for the same value. I mean, it's coming up with error, but let's at least get a proper failure. Okay. Not able to error. Yes. Okay. Back to the lexer. Here's lowercase name. Well. Okay. And let's see. Lowercase name and reserved if tokens. And, you know, I'm pretty comfortable generalizing this even now. I've got something that's going to look up strings and return values. That's pretty much the definition of a dictionary. All right, so let's make one that holds these reserved words. I think I can do a constant, right? So var reserved words is a string to how about taking those quotes off? String to token, and it equals if goes to token dot reserved if. Is that what I call it? Token dot reserved if. Why does it seem resentful of that? Cannot convert value of type nothing to string to specified type. Oh, these go in break brackets for one thing. Okay, and now let's use that. Equals reserved words subtoken substring of token. Okay, I will trust that. Use a dictionary for reserved words. I have to say, like, I had a job for a while helping with the ACM when they were starting to photocopy all their old articles and make the digital library with every article they ever published and all that stuff. And I worked in an office where they sent us a copy of every ACM publication they'd ever printed up to that point, and I was helping with the processing and analysis of all that. I didn't do any scanning, but they had a team that did that. And one of the perks of that was I got to read pretty much any article I wanted on all the old stuff. And something we do like now, a dictionary built-in type, we don't even think about it. It was black magic in the early 60s. You know how you could make a hash and get this quick access without searching and all that stuff. It was just kind of a dark art that the compiler people knew, and it kind of worked its way out to others. And now it's just a little built-in thing, and you get by like this. You don't have to worry about it too much. But yeah, it's pretty cool. All right. Let's just say we're doing reserved words, and let's add another one. We need if then and else. I'm getting a lot of double typed letters. I fear my computer is acting up. Else. Okay, we got to add those tokens. And notice here too, I mean, I'm keeping the token type in here, but it's really an interface type from the parser, between the lexer and the parser. Okay. Reserved then. I guess alphabetical will work. Else if then. That should fail. Both those get the wrong thing. Okay, and it came back lowercase name. That's what we would expect. And we got to add those to our dictionary. Should pass. Okay. All right. I see we've gone for a while. Let's go ahead and take just a couple minute break. I don't know. We might take one more after at 11. But yeah, let's take a 2-minute break. Come back and we'll get the parser working with if statements. I don't think it'll be too bad, but we'll see how it goes. All right. So see you in a couple minutes. Hello, welcome back. All right, so we've got if then else as tokens. Now let's deal with it as a parser. All right, let's find our parser tests. Okay, and we're going to quickly hit the difference of semantics and what they do to parsing. I don't know how we'll break this out, but parser tests. Okay, so let's do an if test. Now, I don't know how we're going to deal with the line breaks. Well, let's just do test if. Okay, so we have check successful parse. Our input is if true, then 30, 3 else 2. Let's keep it all integers for now. And the tree we expect, let's see what we got for tree. We expect an if expression. And it doesn't bother me. Okay, now the trick here is what's in this if expression? Well, it's trees. Because we want to have either int value, float, custom value, could be any old stuff. Okay, and we need to okay. Well, and I don't know. There's let's see. Well, this is the condition is of type tree. Somewhere I have to think we start saying lazy or something like that. Left of type tree and right of type tree. Let's look up something on that. Okay, Swift lazy struct, because it's a recursive struct. Okay, this is not a recursive enum. Oh no, that's what I got to be clear on. Indirect. Yeah, can you do that for me? Yes. Indirect enum. So this says make my enums. Basically, I'm creating indirect says I'm going to use pointers inside, but we don't have to worry about it syntactically. All right, and our parser test, our expected tree is an if expression. Ugh, it gets pretty full, doesn't it? We want a false. That's a tree.custom value. And I'm going to format this a little differently. Well, tree.custom value something, and then a integer value. We did these only indirectly, but we get them in our tree. Integer. What do we call it? Tree.integer. The value is 3. The type is Elm-types.int.number. And tree.integer 2 Elm-types.number. Tree has no member if expert. Okay, let's see. That closes our expression. That closes our parse. Check successful parse. Okay, let's run this. Okay. Okay, what went wrong? Expected. If expression, custom value false, custom type false, true. Okay, we got ignored. All right. All right. So I see I didn't check in my lexer stuff either. Let me comment this out or block it. Tree lexer. Okay. And support reserved words if then else. I don't know if I need to even really check in tree and parser, but we'll let it go. A little sloppiness. Okay. Put this away for now. Okay. All right, and the reason we get ignored, I think we just default to returning ignored. Where's parser? Yeah, default tree ignored. Okay, so we handle int, float, uppercase, name. Let's handle if. Case token.if. Let's call if statement. We'll call a method. Okay, so we're doing recursive descent. So the easy way to think about that is each grammar rule, we just write, oh, this doesn't go here. For each grammar rule, we write a method that corresponds to the rule. So here's our top level parse. That's where we want to come in. And if goes to if statement. So we see the word if, we know we're going to do an if statement. Okay. And function if statement produces a tree. And we'll just return tree dot We'll go with error just to prove we're doing something here. Okay, if statement, return missing. Okay. I'm just refining my error at this point. But now we're going to have to face this issue about blanks. The normal way that, most languages, what you can do is you can just skip blanks in your tokenizer and not return them. Just read them and keep going. Okay. We're going to have to do something. Okay, but we know we come in here, we've got an if statement. And we've read the word if, so we want to skip the token. Now, I don't know if where do we get the token? Up till now, we've not been skipping tokens. Okay, interesting. Well, we got some problems. All right, so the way it is now, we come in here with the if token. All right, we know it's an if. We should be able to call get token, wherever that is. Okay, lexer.get. Okay. This skips over the if. Okay. And now, it shouldn't be a let, that's for darn sure. Var token. Okay. That reveals we've got a latent defect in here, at least a latent inconsistency. When we parsed our single expressions, we didn't read forward to the next expression. So, oops. Okay. We'll get it right. The way the grammar is now, we return explicit space characters. Lexer. All right. So we return this spaces token. I don't want it, but that's what we do. Okay, so here we return spaces. It would be reasonable. See, we don't have to return spaces. We could just call spaces and skip forward. And I think that's what we'll get to do. But right now, we're going to say, I'm going to expect spaces to be next. Okay, so I'm going to, my if statement is looking for this. It's got a new token. If token is spaces. Okay. We're gonna revise this. Okay, so if space, now we want to call an expression and we want to get a tree out of it. Okay, let condition equal expression. All right, and in the end, we're going to return tree dot if expression, and the condition is going to be condition. Okay. Okay, yes. So we got if space true, that's the expression. And then we want more spaces. Okay, token equal lexer.get. And we will definitely improve this. Okay, after the true, then we want our token should be then. Then, all right, and more spaces. You can see why people want to get rid of spaces. Okay, if space bool space then space expression. And then basically this again, except we're skipping the else. And we're going to let right equal expression. And then put left and right in here. Okay, if our expressions were working correctly and skipping stuff inside, this would be fine. But we're going to get a failure. And I really should be checking these words and making sure they're what they say they are rather than just skipping them. But I'm in this kind of push it through mode and see what happens. I expect an error, but let's see what we get. If custom false is not equal to if custom true. Oh, well, geez. At least try to be consistent here. True, true, 3, 2. Okay, let's run that again. I don't know. What is it? 25% of the time my test has got something wrong with it? Something's not right here. Okay. This shows us a couple things. All right. If true, Boolean, integer 3, integer 2 is not equal to true, Boolean, ignored. Okay, because we got some sort of error in the processing. But we got the true, right? So that's something. We're making progress. Hard as it is to tell. Okay, so the deal is up here. We parsed. Well, we parse the value, but we really need to skip over it too. Custom value name. How do we want to do this? Well, no. Each one's got to do it on its own. Okay, we got to, if we read an expression, we get a token int value. We capture the value. I think we can just do the read here. Same thing for float, same thing for uppercase name, because we capture it here. We don't use anything else from the input stream. Okay, let's try that. Ooh, I probably should read this, skip the token, just to make sure we're making progress. One more. All right. Yeah, okay. So we do the right thing. That's good. I guess the lesson here is, like, this is getting complicated. I don't know. When we get to these more complicated things, it's going to be pretty messy to compare, but this is the proper thing. I mean, it's an if statement with 3 levels of tree, so yeah, that's something. All right. Let's not look at the lexer, but at the parser. So we're in a green bar. Let's I got a couple things I want to do. One is get rid of these spaces, and the other is verify that if I expect a then, I get a then. Those generate new tests. The spaces thing, I don't think does. Let's let's make a change, and I'm going to do this well, there's a pretty way and an ugly way, but I'm going to do it the ugly way. I'm going to say if, where's parse? Oh, my lexer. I'm going to put the job on the lexer. And there are probably tests that are going to disagree with me. But I'm saying, at least for spaces, and at least for spaces, let's do this. We are no longer going to return a spaces token. We're just going to call our spaces method. And he's not returning token.spaces. Okay. Let's see how that really. Missing return in a function expected to return token spaces. Yeah, how are we going to make this go? See, really, I want this to be in a loop. Is that going to work? You can see this is a bit of a big leap. Okay, we know it does at this point because that's the only way out of the loop. Okay, now let's indent, reindent. Okay, are we good? So we're saying, while you don't have an end of file character, reset the token, look at the current character. If it's spaces, skip over the spaces and come back around the loop. If it's a real thing, we're going to cut out early and return it. Okay, so let's see if this works. I expect a few tests will break if they relied on the spaces being a separate token or something like that. That's why I'm calling it ugly, because I'm waiting to see which tests fail, and then I'm going to argue that, oh, they should fail. Right, okay, test spaces, return spaces. This thing should actually return EOF if it's all spaces. Oh. Okay. Test if. Yeah, test if should have some problems, right? Because we explicitly looked for spaces. Now we don't get any spaces in our if statement, so we don't need this, or this, or this, or this, or this. Okay, you can see why I like doing this. Come on, no infinite loops. Only 2 tests got affected, so I expect it to work. Yes. All right. So let's commit this. Make it so spaces never get returned. By lexer. Okay. Now let's assess this. So when you call get, this doesn't really need to be inside, because the token gets accumulated. Where's our keep? way down low. Here's keep. It appends the next character to the token, and we're in the middle of building up something. But if we get spaces, we don't accumulate. I don't think skip while accumulates. Let's double check that. Skip while does not accumulate characters, so we don't worry about that. Now let's make this method, let's rename it to skip spaces. Okay, just to kind of bring that out a little bit. And then I don't think anybody should be referencing this anymore. If there are, we'll have to clean them out. Build failed. Well, okay, this is a minus to the end of line. This guy's kind of the same boat. Skip spaces. So he skips until new line. Let's make it his job to own the new line as well. All right, and let's see what else is going wrong. These comments. This one, nestable comments, they get treated like spaces. They should just get ignored. Okay. This one, I can't really do that because minus is going to become a significant character. But if I see this stuff, I'm pretty sure I can, if I skip over the character for new line, okay. And we return token.newline. All right. Anybody else? Token.spaces. Nestable comment. We're going to say this thing does not do anything. And let's. Whew. How do we want to handle errors? I don't know what we have for tokens now. Error, end of file, new line. All right, let's see what happens. If the character is not a dash, then we have brace with no dash. That's an error. So we got to return something. I'm going to make it optional. Okay. All right, and then let comment equal nestable comment if comment is equal to token dot error return token dot error. Otherwise, and I don't know, I end up writing more comments these days on these things. Is there a better way to do this? I don't know. Else treat as a space. Okay, let's see how we're doing. We had 2 failures, right? Oh. Okay. Dash dash n. This should be token.eol. New line. This should be it's kind of the same thing. I don't think this is adding anything because we're not doing those anymore. Okay, end-of-line comment at EOF is okay. What should we do? If we get if we get dash dash at the very end, I think that should be a token new line or a token EOF. Let's try this one. I'll accept either one. Nestable comment returns spaces. No, that should be a token EOF. Non-empty nestable comment returns spaces. It should be, let's put a number here. It should be the integer. Nestable comments ending with many dashes, no spaces, returns spaces. Well, no, it doesn't. It's going to return whatever comes after. So this token end of 3. Nestable comment can mix dash and non-dash returns, well, I will say ignores spaces. Or treats as spaces. Maybe that's the way to say it. Yeah, no, I think my integer strategy is the better one. And 9. Treats as spaces. Okay, we'll throw in a 0 here. This should really just be token.int of 0. Can I convert? I think you lost track of the plot there a little bit. Okay, this becomes token.int. All right. Did I call it something different? Yes. Check token. Okay, unterminated returns error. That's true, true, true. Okay, let's see how we're doing. One failure. Yeah. Not equal to new line. I think new line is acceptable to me. I don't think it's going to make a difference. Because you'll come back around again. It's EOF. It's always EOF at the end. All right. So this is a big switch over from the spaces point of view. Make spaces be ignored instead of a separate token. Now, some languages, this is not a requirement. Okay. Oof. Parser tests. All right. Now we got, where's our parser? All these things where we say, this one's fine because you know you came in with an if. All right. Condition expression. But this one, we need to check. Okay. So let's make a test where let's say there's no is there no then? Let's just leave off the then. They wrote some Swift code instead. So here we go. This isn't a failed parse, actually. Okay. Check failed. And we're going to have lousy error messages like this. So, oof. But I think this should just be tree.error. Oh, it's already built in. All right. I think we can make this a one-liner. Shoo, boy, I don't know what'll happen. It may already fail. Nope. Okay. Error is not equal to, it tried to do something. Yeah, it just sort of blipped out these guys. All right, so let's say we have, what I want to do is say if token not equal token dot then reserved then I want to return an error. Okay. Yeah. Okay, and I want to change this to be function require. And it's got a token. Okay, so I'm really trying to say require token dot reserved then. Oh boy, I gotta check the return value. Oof. And it's like, how do I get an error message back through something? I gotta do some sort of check. If it's not the expected thing, return error. If it were Java, I would just throw, but I kind of don't want to get into that here. But if I don't, then I have to do if required, blah, blah, blah. Yeah, how do I do that? Oh. You'd think I could remember Swift a little bit better. Swift exception example. I can throw an error. Do I have to define my own types? Can throw errors. Well, let's put throws on our require thing. And he's going to throw if he's not happy. And then somebody's got to be catching it. Do catch. Okay. Throws. Can I do this? Just no. Okay. Let's do this. Do catch. And then we want to return tree.error. All right, and we're putting this, okay. Token is a var. What are you talking about? Oh, I named it. Let's call this expected. Error does not conform to error. Okay. Am I going to have to define a type? I guess. All right. Okay. Yeah, like I said, syntax handling, the error handling definitely makes things much uglier. All right. This should be working. Okay. Now, what's going on? Error is not equal to true if tree. True. Ignored. All that and we're not getting it, huh? Well, wait a minute. How about if token is not equal to expected? All right, so we should have the then. It should be equal to expected and just go through and get red. All right. Thank you. Okay, and let's do the corresponding one with an else. If true, then 3, 2. Okay, we expected error, but we got an attempt. And we got to do the same kind of thing here. Reserved else. Okay. Not bad. Condition equals expression. Take the then. Left equals expression. Take the else. Right equals expression. Return the tree. Just checking if anybody else can use this, but I think that's enough. Okay, so let's see. We handle parsing of if statement. All right, now, we got semantics. Okay. Oh, my to-do is way behind, isn't it? Let's get this together. Okay, handle custom type Boolean story. Ignore spaces and comments. We did that, and we did a handle if statement. And we're working on that one. All right, and the two things we need to do at this point, it's already kind of getting to the end of the day, so I don't know how far we'll get, but one is we've got the parser. So the classical breakdown, I don't know where my hands are. Lexer, parser, so lexical analysis, syntactical analysis, and then semantic analysis, and then code generation or interpreter or whatever. We need to do semantic analysis for the if. And we need to interpret the if. Okay. So the way it is now, let's write a test. Go figure. Okay, test if with wrong condition type fails. is this a parse error? Not really. Okay, but if I say if 42, then 3 else 2, it's got the right structure, but it should fail, and it's going to come back instead with an if expression that's got a 42 and a 3 and a 2. But we checked in the Elm REPL, and we need to enforce the condition. Hey, it did fail. Oh no, it failed the test. It came back with an if expression 42, 3, and 2. Okay, so the parsing of it is fine. Yes, it takes an expression. The failure is the expression on the condition is required to be of Boolean type, and we don't enforce that. Okay. This makes me think like our error handling is we're already kind of in a bad place, right? All we do is say, "Oh, you got an error." We'd like to say, well, we'd like it to be as nice as this. If 42, then 3 else 2. I don't know that I have to be quite as fancy, but I want to say at least the condition of an if must be of type bool. Okay. Just that would be progress. Okay. And let's see. So the two semantics we're enforcing. Okay. Let's see. This is non-bool condition type. Okay. So that's one thing we got to enforce. Okay. Condition must be bool. Then and else clauses must be compatible expressions. Okay. And we can see this in the REPL as well. So if true, then false, else true. That's compatible. And if true, then false, else 42 is not. Okay, so numbers are compatible with numbers. And it looks like the more, well, somehow it knows it's forcing it to be float. Okay, we'll have to look at that. That's a little tricky. But it definitely knows the difference between a number and a bool. Okay, so we will pick up there. And the way we'll do it, we basically have to augment. So we had our basic recursive descent function, and then we added in the do catch stuff to handle errors. Now we're going to add in some conditions, some semantic conditions. And again, we're augmenting this thing. You could build up the whole thing, and then at the end have a pass that just goes through and verifies that all the conditions are right and things like that. I don't know. This is kind of like right on the edge of what I would call understandable, and I hate to make it a little more complex. It's not terrible, but yeah. Anyway, next time is tomorrow, Thursday, 1 to 3 p.m. Eastern Time. I hope you can join me, and I hope you have a good evening, and I'll catch you in the future sometime. Thanks. Bye-bye.